Okay.
Started. And if you don't mind, I would like to introduce our community to you, and so our viewers also, first-time viewers, can see when they watch the video. Then we will start with your introduction and continue on. And let me start. We are Reinforcement Learning Turkey. We are a community that started officially in the May of this year, but we were doing other stuff and privately, mostly friends, since last or 2 years ago. And we are mostly, nowadays we are mostly creating video interviews. We are trying to make a bulletin series. We are also trying on the hackathons and other code challenges as well, along with like social things like this. And that's our goal mostly. I mean, reinforcement learning is still a niche topic compared to other machine learning area.
Yeah, it's interesting.
I mean, yeah, the area isn't like very high, but we are trying to improve like the visibility of the area mostly.
Yes.
And that's it from you. Can you introduce yourself? So
yeah, sure. I'm a PhD student and candidate in aerospace science and technology in UPC, Universidad Politécnica de Catalunya, and I'm working on drones and deep reinforcement learning. Mostly I am focused on now counter-drone technology. And now I am in a research group called Icarus, Intelligent Communications and Avionics for Robust Unmanned Aerial Systems. This is a part of Research Center for Aeronautics and Space in UPC. And I publish a couple of papers, articles. Some of them are conferences, some of them are journals, and mostly related to the drone delivery and autonomous drones and counter-drone technology, how we can counter a drone. Because nowadays we have a lot of drones and there should be another drone to take care of this also in terms of security, public security or privacy. And yeah, I like deep reinforcement learning, and I try to focus on how can I use my because I am doing system identification, guidance, navigation, and control subjects and designing autopilots. But deep reinforcement learning is another subject to talk about because you can design the known autopilots with the known subjects, like you can use PID control, model following control, robust control, adaptive control. With deep reinforcement learning, it will be a new area, maybe intelligent flight control, and that's why I am trying to focus on. I am not very long time, actually, I am working on this. It has been like 2 years, and it's very good. I am learning also, as all of us, and I am trying to improve myself in this area. I try to attend some, we have deep learning Barcelona also, maybe you heard. I attended that year. Yeah. It was very nice, and there are lots of people are working on these subjects, and they try to communicate and discuss and share ideas like in blogs in the internet. But it's a very good subject. That's why I am working on this. And yeah, I am still continuing and try to do my best.
Sure.
And thank you for hosting me today.
We thank you for accepting our invitation, because your topics are very interesting. Our viewers probably will love it after we record this. And maybe you can start your presentation if you are ready.
Yeah, I prepare a small presentation about my recent work. I publish an article in Sensors in DPI about counter drone and deep reinforcement learning. I will show a very interesting results, and we can discuss later on this topic. Okay. I will share my screen then. I think it says host disabled participant screen sharing. Is it okay to?
Let me open it. Can you try it again? Maybe I should
Yes,
open
I
it.
can. I can share it now.
Okay.
This was the thing here. Okay.
Yeah.
Hide this. Okay. Now I am trying to talk about this counter drone technology and deep reinforcement learning. And first, I will start with the goals and objective of this, and I will explain a little bit counter drone techniques and then research activities, and then I will give some supplementary links to support this idea. And the main goal is to propose a new alternative deep reinforcement learning method to provide safe integration of drones into the public areas, because we will have actually a lot of drones in this area, and then we need to take care of it. And the overall objective is we try to implement deep reinforcement learning algorithm for counter drone technology in Airsim simulator now. Later, we will implement this algorithm to the real drone and try to test this in the real world. And nowadays, there are lots of available techniques to counter a drone. It's one of them is jamming, netting, spoofing, laser, machine gun, electromagnetic pulse, water projector. There's a drone sacrificial collision drone, and I am using this actually now because I tried to sacrifice one drone in simulator to crash on it. And the others, it can include a lot of things. For example, in one of the countries, airport using animal eagle, the birds, and try to catch the drone. It's very powerful. But you need to train the eagle. It was in Netherlands, I think so. And artificial intelligence is in part of this also. It's a very neat topic. Not much people are using it, but mostly in commercial side. But there are radar systems also, but in military level. And my latest publication is about counter drone in a complex neighborhood area by deep reinforcement learning. We try to avoid obstacles also while we are trying to catch the counter drone. And the tool and toolkit is Airsim simulator. Is an open source, as you know, Microsoft simulator, and it's based on Unreal Engine. It's very good. You can realize you are using a very good physics in this simulator. Before I was using Explain in my master thesis, but we didn't use much Explain for visual imaging, and mostly in deep reinforcement learning area, we understand this Airsim simulator is best for now. The other ones also, but Airsim is very good for this. And OpenAI Gym, for, as you know, it's very good to communicate your agent and environment. And the basic areas in TensorFlow class reinforcement learning. And to begin with, the Airsim simulator and Unreal Engine. This is on the left, you see the my image actually, first person view image. To see the drone here, we have 3 different camera. We receive images from this simulator. I am using on the left one, and then I process this image. And this is the drone, quadcopter drone. Actually, this drone is tested in Airsim. They say this is very good in real time also. They compare the simulator results and the real world results with a parrot drone.
Yeah.
You can find some publications about this, and I will do this in the future also.
Yeah.
And this was the map of the neighborhood. And I have a learner drone here, as you see on the bottom.
Yeah.
Random drone and the target drone. This random drone, I call it random drone because it moves randomly in this blue shade, yellow shaded area. And the target drone is moving on the red shaded area. They are moving randomly actually. If you are doing this randomly, reinforcement learning is not easy to catch this also. We try to challenge this actually. Sometimes we try to stop this moving random drone and we make it stationary. And the results were very interesting. I will show them soon. And we processed the depth image you see on the left, 144 by 156. And this is the processed area of 20 by 100. And we have a 3 by 10 black line here. And this black line represents the target angle. And it moves left and right according to the track angle of drone. We try to catch the drone and position the drone. And this will move like this. And then we try to implement this in the RL algorithm. And in this, on the right, you see the grid lines. Starting from the top, there is not much. In the middle, there is a little bit. And the bottom one is almost black. And this is a depth image, and we try to implement this because we have a geofence system, virtual barrier for drone, and it's very common in drone area. And this was very important for us because when I try to implement the reinforcement learning, we realize the drone crashed a lot of times in the beginning to the geofence, because geofence you cannot see easily. You cannot see actually because it's not visual. And we implement this when we are getting closer, we can get this as an obstacle, and it's getting more black and black, and maybe the drone can understand it's obstacle for the drone. And I think it was almost success because we realized we have less collisions. Before we had a lot of, and now we have less. And then we have auxiliary inputs, scalar states, and we concatenate these scalar states with the image. And we have velocity of the drone, the distance to the goal in X and Y directions, and track and elevation angle. We get the elevation angle also because nowadays we are working on 2D, but I'm gonna do it on 3D also. Nowadays, the next topic is in 3D. It's a little bit more complicated because we need more training time for this. The distance to the geofence limits. And we have maximum, minimum. It's like you can, the laser guns to calculate the measure and measure the distance. And it can, if there is another obstacle, you can see 5 meters, or if it's further away, it's 30 meters or something. It's very important, geofence limits in this topic.
Yeah.
And we have actions. This architecture, the output of our neural network gives us go straight movement in direction of the heading with 4 meters per second, and to go right. And I use the exactly same rate, 30 degrees per second for your left and right, your right. But we have another paper. It was using the other different kind of attitudes. If you are turning 30 degrees per second left or right, you will turn the same one and you will not see the difference. But this was okay also for us. We have tried the different things also. And this is our agent, our brain now. And we have the convolutional layer. After that, flattening layer. We have the concatenation layer with the scalar inputs and the image input. And then we have fully connected layers. At the end, we have the output layer. It's a dense layer. We have the 3 actions. In this topic, actually, I tried many actions here because we try to find the best option to go to fast. You need to be faster to catch a drone. You need to be precise. You need to get rid of all the unnecessary movement. And that's why I try to reduce a bit this movement. But in this, I will upload a video later. It's not available now in YouTube, I think. So we have the other videos. You will see this drone is gonna stop when try to turn. You will turn left or turn right because you try to, I give him some time for thinking. And these are rewards. It's a very common one. Only difference is for track angle. And this is 100%, 100 plus 100 is the, when it's success. If there's a collision, we say, okay, you have a collision, and it can be a collision on geofence also. And we have intermediate rewards. I included track angle also, because I try to give the penalty when the drone is not facing the target. I try to push the drone to the target. And we have a lot of trainings, and I will show the results of some of them, very interesting one. The other ones are in the paper also. And first, we put the drone on 30-meter altitude to get rid of all the stationary obstacles, ground obstacles on the simulator. And I train it with only, first one is only the target drone and the normal drone, our learner drone, the agent. And later we added an additional third drone in the middle to challenge our drone, and we use transfer learning also in this topic. It's very interesting because before transfer learning, you have a lot of time to train, full training. Like we were waiting 2 days for this. It's like 125,000 steps, and it's not easy because when you have 3D also, you need more, and you need to have more time. But with transfer learning, at least we can transfer some experience from the predefined model to the new one. And the third one is we add a movement. It was not non-stationary anymore, this third drone, and it moves around the environment, and it will be very good challenging option for us. And we use the same transfer learning also from the baseline model. We transfer the predefined model from the baseline, which means there is no other obstacles in the middle between this target drone and our learner drone. And in case 2, we go down. We have used ground obstacles also, low altitude with many obstacles, like there are cars, trees, houses, and we have drones also. And we try with transfer learning and without transfer learning. And the results were better in transfer learning. And this is the baseline model on 30 meters altitude without any other drone in the middle. And as you see, the drone learned actually very fast. In 30,000 steps, it's almost non-crashing. We have only one crash here. Man, it sometimes happens with the drone lost in geofence, and we penalize this. And then these on the right, the drone position map. These all small dots you see represents drone location in one time step, discrete time steps. And this red dot is the starting point of the target drone. Actually, the target drone is moving also, but I didn't paint this, only I showed the idea of this drone position map to show how this drone learning to move to that target. And as you see, these are the range. I just created a X and Y direction plot to cover all the geofence area also. And there are some crashes on the left side going to the minus 70 Y direction, and it's a crashing for geofence. But we don't have much crashing in this part because drone is almost focused on the target. As you see, there is a dense cloud in the middle. You will see different clouds in the next pictures. And this is the, we put another drone in the middle. One of them is moving and with transfer learning. And if you look at the picture on the right side, drone map without transfer learning try to cover a lot of areas, try to learn what's happening, because the difference between this and this one is there is a middle drone, random drone, and it challenges our drone. And it's very obvious here. And drone tried to catch another drone, but he tried to avoid another obstacle drone also, because when it's closer, it will understand there is a drone and it's an obstacle for it also. But with transfer learning, we get rid of a lot of negative collisions because we have positive collision about drone also. We try to avoid the other drone collision, and we try to avoid geofence collision also. It was very successful, and you will see on the left, without transfer learning, the drone is learning, and then after 20,000 steps, it starts going down, and then try to learn again. But with transfer learning, it's almost stable. In 50,000 steps, we were above the 100 range, and it was like a threshold for us. And it was very, very good result for transfer learning. And this was the ground results. And on the ground, we have a lot of obstacles. That's why we have a lot of crashes also. And we have stationary obstacles, and we have another drone. With transfer learning, we get rid of a lot of crashes again. But and you see it here in this drone position maps on the top side and the bottom side. There's a little bit less collision on the bottom side, bottom picture, this one. And you will see, actually in this map, there is a house here on the minus 20, minus 10, Y direction. You will see a little bit white shade here. And drone cover all this area, actually. It's very interesting. And the second one on the bottom, you will see a little bit circulation around the red dot also. Drone is going away from the drone, target drone, but he learned before and he's coming back to catch the drone. And it was very, very funny also because he was going and stopping and coming back. Sometimes I watched the drone actually when I was training, because in training, I don't want to interrupt the computer in the lab because it can cause a problem. Sometimes I have a lot of crashes in Airsim. It's still developing, but it was funny to watch when he's training also. He's coming back again. And this was the training results of transfer learning comparison. And you will see a jump start here actually. It's a very good result for us. We will see almost 35 mean reverse jump start in the beginning with transfer learning. And we reached the top actually because our maximum threshold is 120 and it was almost in the same line. But without transfer learning, the process takes a lot of time, and we achieve almost 10,000 steps, a very good result with transfer learning, but without transfer learning, we have less. And this was the ground scenario, the crashing, the number of crashes, the crash report. And as you see, the defense crashes, it's a lot of crashes at the beginning.
Yeah.
And this was all trading actually. As you see, the numbers are getting less and less, and it's obvious we transfer experience from the predefined model, and the drone is already learned something and add something on it. We try to implement the last layer of this model. Actually, we didn't try to train all the layers. It's not the case, but it was a very nice idea to use the transfer learning also for reinforcement learning. It's not easy sometimes because you can have a lot of problems with transferring knowledge because it's not the other kind of method. It improves a lot and it was very good for us. And this was not in my paper actually, I didn't put this, but it was very interesting for me. The drone one velocity, this is the map of X and Y direction, how it focuses the drone, because on the positive side of X is the powers the target drone.
Yeah.
And you will see the lines and the shapes is mostly focused on this positive X direction, but we have a lot of directions in this X and Y cross sides. Because this was taken from the full training and it covers in the beginning because he's learning, exploring, and it was very interesting. And these are the supplementary links. We have YouTube video samples for our first paper. I was co-author in this, deep reinforcement learning for drones. This was about the drone delivery, but we don't catch a drone here. This was not a counter drone. We have a stationary position and the drone is trained to move to the target position. And I have multi-threading in Air Simulator also because I was trying to use a multi-agent system also, and we implement threading. Multi-agent system, I am not working on this now, but I will try to implement this also because I want to use the same experience and share this experience with the other drones. It was very important because if we have a lot of drones in the area, we can cooperate with these drones and maybe we can learn very fastly. And these are the references and it's the same as like my publication. So there are lots of things actually to talk about this.
Yeah. I already have a lot of list of questions.
Okay.
And
we can
start with them. And thank you for your presentation, by the way. It was great. And
thank you.
I also want to check out that multi-thread implementation because I had also problems with Airsim. The Unreal Engine is very heavy engine compared to other simulations. It causes a lot of problems. So my first question that I recorded, you talked about some neural network architecture called joint neural networks. I believe it's specifically designed for your case. I didn't see it.
We call it your neural network.
Yeah.
Before me, there was a student of my professor. He was working on this also. And it is mostly about this joint section of the neural network to join this image state and the scalar states. This concatenation layer actually. And it affects all the learning. And we try to implement this idea, but sometimes it can confusing also because if you use a lot of scalars, when we try this like track angle, elevation angle, and different subjects, and it can.
Do you think
misleading also? Yeah.
Do you think this also can be approached to other situations with the reinforcement learning, besides like drones, like maybe robots, games? Because most of them, in the simulation you have access to other data.
Yeah, you can receive a lot of parameters, and it's very important to take these parameters because you will have a lot of information, but you need to choose correctly which parameter is very important for you. Because if you can mislead, it's a disaster for your drone because any other thing. You can use a vehicle also, autonomous vehicle. And it's very important which one is your important parameter. For example, in my case, I need velocity. I need the distance to the target. I am calculating in the discrete time steps. It's very important, these parameters. But of course, you don't need all the parameters, and it will take a lot of time to train these and it can cause problems.
Yeah. I have also another question about your reward engineering process. And you created a reward mechanism for your simulation or your training process. And how did you come up with this design? Is it a common design? Because it's kind of feels a sport, maybe like a sports wars. Because how did you decide the rewards about creating?
These rewards, first we have the intermediate rewards, because we try to avoid a lot of wasting time, and we are giving penalizing and -1 plus, and as I show in the presentation, we have -1 plus delta distance, the distance to the target, and then we have a track angle also. These are intermediate results and the rewards, and we try to update this reward with these intermediate rewards. And I have a limitation also, maybe I didn't mention this here. I have a time limit, maximum 5 minutes or 6 minutes. And if it's reached this time limit, and you will see intermediate rewards will be like -300 plus something, and it will stop and restart the episode. The strategy was like this.
Okay.
It doesn't matter you reach the target or not. Yeah. If you reach the time limit, I penalize and I restart the process.
We have another question from the chat, and Berk asked if the length of the episode changes depending on your training process.
Yeah, this is the same response actually. This is, if the episodes changes, I have intermediate rewards, and intermediate rewards will be higher in positive sides or negative sides. If it spends a lot of time, like 4 minutes, it will be around -200, -200 plus something, and it will be more negative rewards.
And I have another question, and it's regarding to your maybe future experiments. You talked about it, but you will talk about it. But it's about transferring your policies into the real world. Did you look about the approaches? I believe there are a lot of ways to think about this, because some of people do maybe a lot of the training in the simulation. How do you approach? How do you think to approach simulation to real transferring?
Yeah, there are lots of options actually. First one is try everything in the simulation, modelize your simulation area in Unreal Engine, and train this, and then try it in the real world. And the other one is train your drone in the simulator, and then try it in the real world without knowing your environment exactly. Actually, we are using this reinforcement learning for this, because we try to be robust, and we try to get rid of unknown information because we don't know the environment, and the reinforcement learning is very good for this. You don't need previous knowledge on this actually. And drone is learning to act something, and that's why I am looking on some subjects on, for example, the biggest problem may be the hardware, because we have very important algorithm and it requires a little bit more power. But we try to train in the simulator first, and then we try to test in the real world now.
Yeah.
That's why I am thinking on this. But maybe if we are successful enough, we can train in the real world also, because we have a drone lab, research lab, and you can train and test drones. And it's a very good. The only problem is if we crash a lot of times and we can't use the drone, and we try to get rid of this, and we try to use more simulator in the beginning, and it will be nice. But the important thing is which hardware we are gonna use. And I know there are some hardwares like for reinforcement learning, NVIDIA gives us actually, if you are a researcher or educated, if you are using like university researcher, they give you freely, I think so. It's like a contribution. And I am trying to avoid a lot of cost also, because the main idea is try to use very good algorithm, very good method to implement this in a less cost, because we try to use this in a real world, this counter drone technology. And that's why it's important to use available resources and use, actually nowadays I am working on computer vision also. I try to detect drones by using the object detection, this state-of-art real-time object detector. One of them was YOLO. I like YOLO, it was very nice. And I prepared some paper, maybe later it's gonna be published.
Yeah.
And I try to implement this in reinforcement learning also, to get the drone, and we try to estimate the distance and calculate the distance between the target drone and our drone by using the image. It's a bit tricky process, because this Airsim simulator giving us some camera metrics as a projection metrics, and we are not sure about the metrics actually, because it's not precise. It can cause a little bit problem with the rotations, and maybe the Microsoft update this and we can have more specific things. And this was very important for me also in the real world, because if you have the image, we can estimate from the because in simulator we have a lot of parameters which is not available in the real world.
Yeah.
Because if you are in very limited area, like without GPS, you don't know the position of another drone. In this simulator, we have the positions of target drone. We already know this. We are getting inside this, and we put in our algorithm and calculate the distances and the other things.
Yeah.
It's another limit, disadvantage in the real world, but in the real world, you need to improve these things by another methods.
Thank you for your answers about that. And I have also another question regarding to mostly your hardware choices, maybe the camera choices. Use the depth camera. I
Yes.
wonder if there is any reason why not maybe using a RGB image or maybe another method like
depth image. This depth image is mostly gives us the, as you know, if there's a very black lines, black areas, you don't easily understand. It's like a grayscale, and it can understand very fastly. And it's the most common way to use the depth image. Actually, you can use it in the real world also. You can buy a depth camera. There are very good ones and very cheap ones also. But with RGB images, we try to implement for this object detection. Actually, we try to use this for this idea, and that's why we are using depth image.
Thank you for that. Did you consider something like LiDAR, maybe mini LiDARs? But
yes. I was thinking on this also, but I didn't implement. Airsim is developing now, and they added some LiDAR sensors, and you can get some scales, but it's not precise now, I think so. There are still issues.
Yeah.
But the LiDAR is another good example actually. We can visualize the environment, map the environment, and we can understand all the obstacles, where are the drones and stuff. Yeah, I can use the LiDAR later also. I am thinking on it, but it's not in the case, not the case now.
I also have another question. It's about maybe a little technical side of the drone, but with all these cameras and sensors moving with a very like heavy algorithm compared to others, how does the battery life of the drone affects all this? Maybe in the real life, not maybe in simulation.
Yeah,
but
in real life, yeah.
Yeah.
Yeah, it can affect a lot actually, but we try to use a very specific mobile hardwares to use these subjects. There are some studies on this, and we try to learn from them also. But yeah, the real thing is, if you train in the simulator first, you will have a lot of time to test also. But if we train in the real life, probably it will not be easy for us, because it will take 2 days training almost now. And with this powerful we were using GeForce NVIDIA card for training in the lab, but this was very powerful compared to the mobile cards. And as you know, it requires a lot of power it will reduce our battery very fastly. But we will implement this for mobile version, and I think we can get rid of the battery problem. Not exactly, but yeah, we can do that.
Yeah, I also have another question. It's still related to maybe a real world drone, or maybe it's also related to simulation as well. It's about the inference speed of the simulation or the real world. You have in the like a reinforcement learning algorithm, your agent has to decide some Q state or whatever to take an action. I mean, this takes times compared to other methods, so drone can go maybe other ways while doing this. How do you like deal with this problem, like your inference speed? Your drone basically stops while thinking to next action.
Yes. Actually, if it stops, if it doesn't move, we penalize it with the intermediate steps. We give -1 if he stays stationary. We give -1, -1, -1, and if it goes away from the target also, we are penalizing in these intermediate steps. That's why the drone is learning. If he waits a lot of time to think, it's penalized, and we have less rewards. And in our algorithm, this improves in time with intermediate. This intermediate rewards is very important. And if you are correctly implementing this, you're gonna get bigger rewards in the beginning. Otherwise, you can have less one.
And another question, and then I will read the last two on the chat. And you talked about the like transfer learning, and I was wondering what was the base for the transfer learning? Was it the like a policy from simulation, or maybe image feature extraction network or something like that?
I take some layers of the train model. I transfer these layers.
Yeah.
And this was the common way actually.
Yeah.
But I tried another thing also, but I didn't test much. I tried to change the specific location in these layers, like matrices. It was very interesting. You can use this, you can see these files and the model file inside what is the matrices. There are lots of very big matrices. And I tried to change these matrices with the predefined model. And it was not very successful, but transferring with the layers, it was okay. And you can transfer some layers. But with the simulation, no, we didn't transfer any knowledge on simulation, just for the knowledge from the training.
Yeah, okay. And from the chat, there was a question regarding to input values. And you mentioned you used like a discrete three actions with your
Yes.
simulation. Did you like try other inputs, like maybe continuous inputs or something else? How did they result? Like,
Different kind of input values. We didn't try it. We always have this discrete ones.
yeah, okay.
You can use it also, but there can be some confusion in these layers.
Yeah.
I try some different time schedules also. I try to increase the simulation steps to move forward, and I try to increase this space also as an input, like a time, increasing the time actually, but it causes some problems and our success is very low in this one.
Yeah, okay.
We try to stick on what we have now.
Okay. We have, I think, end of the questions, and I want to thank you for today's presentation. It was very helpful.
Thank you, sir.
I think for people who are interested in drones and the reinforcement learning. And yeah, if you have anything else to say.
Yeah, thank you for the invitation also. It was very nice to talk about this. In Turkey, I know there is a deep learning community. I saw in the social media also.
Yeah.
And it's very important actually, because this artificial intelligence and deep reinforcement learning will be very hot topic. It's still hot topic, but it's gonna be more soon, because we will have a lot of things with working on deep reinforcement learning probably. Not
Yeah,
just,
probably.
yeah, we will have kitchen robots also probably to train, because in OpenAI Gym they are adding a lot of environments to robot arms and walking simulator also. We will have this in our world probably. And as a drone subject, the problem is with the reinforcement learning, how we are gonna communicate with the other drones in the, for example, we have an air traffic management system in the commercial airlines and the others. We will have another one, unmanned air traffic management also probably. And this will require multi-agent deep reinforcement learning, I think so. And that's why I was trying to learn from this also with multi-agent systems. It's very important because there will be cooperation, but there will be another kind of non-comparative ones also. And maybe in airports or another restricted areas, we try to combine all the drones who is getting inside, and we try to follow one drone, maybe like a police drone, into the station to take all of them. We need a multi-agent system in this. And these are the new topics actually, and we will learn more on this soon. And now our first objective is to create a ground to drone technology in real world now. Now we are basically on the simulator, but we have some limitations on simulator also, because we try to get updates from the Airsim, and if there is an issue or when they add something, the program behaves very different also. And
yeah,
we need to get a more stable version, and I try not to update everything in a short time. But it's very nice. And I saw your projects about the drone racing also.
Yeah, that was also based on some competition from them.
Yeah, it was nice also. And I think Microsoft has a lab, as you.
Yes, yeah,
Drone
there's a
racing
Airsim
lab.
racing lab. But I also experienced the same problems as you. They were updating the code too much, too frequently,
Yes.
without documenting enough. And yeah, I don't know, that's probably given compared to it's a small project and mostly research thing.
Yeah.
But yeah.
Yeah, well, it's, in general, they are doing a good job actually, updating things, but we, we try to update less for them.
Yeah, we are kind of lazy.
They can update a lot, but we cannot update a lot of times.
Yeah.
I try to use different versions of operating system. Sometimes I use Linux, sometimes I use Windows.
Yeah.
I try to test things in the Linux mostly.
Yeah.
And it's very helpful also. But it's in general, it's very nice because they added a lot of things like weather also.
Yeah.
In our case, we don't have a different weather condition. We have a clear version, but maybe we can add winds and the other disturbances, and it will affect our learning probably. We can compare the new results, but we didn't compare it, and we try to focus on to catch the drone now, but we can add a lot of challenges in Airsim now. It's very important. And in real world, we will have this. We will have wind gust, wind shear, and different kind of disturbances.
Yeah. Again, I want to thank you for joining us today.
Thank you very much. Yeah.
And have a good day, I think.
Thank you very much. Yeah.